Iter, it is a project based on tokamak, and its goal is to harness the energy produced by the fusion of atoms. It is very highly efficient as compared to normal power plants, as it consumes very small amount of fuel and also doesn't emit any greenhouse gases. Many people think that it might be disastrous, but it's not, because there is no possibility of runaway reactions as fusion conditions are precise. Any alteration in these conditions and the plasma cools down in seconds and reaction stops. The fusion reaction that takes place inside this project is deuterium and tritium in plasma form at temperatures above 150 degree million centigrades, forming helium ion and neutrons. To achieve this temperature, we need to heat plasma. For this, we have two methods. The first one is a neutral beam injection. It consists in shooting high energy particles in the plasma. Outside the tokamak, charged deuterium particles are accelerated to the required energy level. These accelerated ions then pass through an ion beam neutralizer where their electrical charge is removed. The high velocity neutral particles can then be injected into the heart of the plasma, where by way of a rapid collision they transfer their energy to the plasma particles. And the other is with the help of the high frequency electromagnetic wave. The energy carried by high frequency waves introduced into the plasma is transferred to the charged particles, increasing the velocity of the chaotic motion and at the same time their temperature. At this high temperature, we cannot let plasma come in contact with any of the side walls, as nothing can bear this temperature. So we need to confine plasma within limited space. So we use tokamak. Tokamak confines the plasma using magnetic fields. Two types of magnetic fields are used in this. One is poloidal and the other is toroidal magnetic field. The result of these magnetic fields is that plasma moves in circular helical path, which confines the plasma just within the region where the magnetic fields are present. Let's see how Iter will produce energy. We inject the two elements, that is the deuterium and tritium, into the tokamak. These will get heated with the help of the plasma heating methods that will raise the temperature to the 150 million degrees centigrade. At the same time, tokamak will not let the plasma to touch any of the side walls. At that temperature, fusion reaction will occur and helium and a neutron will get produced as a product. Since these neutrons are neutral, they will not get confined in the plasma region, and as a result, they will come off to the plasma and they will get absorbed by the walls. Since their speed is very high, they will transfer their energy to the walls. In Iter, this heat will be dispersed through cooling towers. This heat will be used to produce steam, and by the use of turbines and alternators, electricity is produced.